Hi, West Hanover. This is Mr. Neff, and today we are learning about how we can use compatible numbers to help us estimate an answer to a division problem. In other words, find out an estimate to a quotient, which is the answer to a division problem. Please open up your math journals to page 113. That's page 113. If you'd like, push pause on the video so that you can get caught up to page 113. All right, on page 113, you can see the unlock the problem. We have a word problem. Let's read it together. It says, the observation deck of the Willis Tower in Chicago, Illinois, is 1,353 feet above the ground. That's huge. Elevator lifts visitors to that level in 60 seconds. Imagine how fast that is. You can make it to the top of the Willis Tower in just 60 seconds. About how many feet do the elevators travel per second? Let's circle the word about. You know, that's an important word in this word problem. It tells us that we don't need to find an exact answer. We just need to estimate an answer. So if we just need to estimate the answer to a division problem, using compatible numbers can be very helpful. You can see that the math journal on page 113 has already showed us examples of compatible numbers. They've rounded the dividend 1,353 feet down to 1,200. They've kept the divisor 60 the same. So you're probably asking yourself, well, what makes 1,200 and the number 60 compatible with each other? The answer to that is 12 and 6. They are compatible. Why are 12 and 6 compatible? They're compatible because 12 is a multiple of 6. Therefore, 6 is a factor of 12. So since they are compatible with each other, they're easy to divide in our head. We use the basic fact, 12 divided by 6, which I know is 2. Ooh, that's a sloppy 2. Let's see if I can fix that up a little bit better. And then we use the zeros on the end. Instead of in multiplying, when we count them and add them together to find our answer, we actually use the difference between the number of zeros in division. So since 1,200 has 2 zeros and 60 has 1 zero, the difference between 2 and 1 is 1. So I'm going to add 1 0 to my answer. So it looks like the Sears Tower, you could say, it goes 20 feet every second. That's pretty fast. Now here's another way that you could use compatible numbers to come up with an answer. They rounded 1,353 feet all the way up to 1,800 and kept 60 the same. You're probably saying, well, what makes 1,800 and 60 compatible with each other? They're compatible because 18 and 6 are compatible. 18 is a multiple of 6, and 6 is a factor of 18. So again, we'll use a basic fact to find our estimated answer. 18 divided by 6 is 3. And the difference between 2 zeros and 1 zero is again 1 0. So 2 minus 1 makes 1. So these are two estimated answers for how many feet the Sears Tower, or the Willis Tower, can take a visitor in 1 second. Let's take a look at a few more problems with compatible numbers. Please turn to page 114. And this example says Miriam has saved $650 to spend during her 18-day trip to Chicago. She doesn't want to run out of money before the trip is over, so she plans to spend about the same amount each day. Estimate how much she can spend each day. So since she has $650 that she wants to separate evenly over her 18-day vacation, we know that we need to divide, since we're separating this amount into equal piles of 18. So in this case, we want to round again, use rounding to come up with compatible numbers. The book has suggested that we round 650 down to 600, and that's fine, but now we need to take a look at our dividend, and we want to round 18 to a number that's divisible with 600, or if we just look at the first couple digits, 6 or 60, to make it easier on ourselves. So I know that 18 is in the tens, and it's really close to the number 20. So if I round 18 up to 20, I have to ask myself, well, is 600 compatible with 20? The answer is yes. 6 and 2 are both compatible with each other because 6 is a multiple of 2 and 2 is a factor of 6. So 600 divided by 20 means that Miriam could spend about $30 each day and she shouldn't run out. Or I could round 650 to maybe 800. So if I rounded it up to 800, excuse my sloppy writing, 8 and 2 are still compatible with each other because 8's a multiple of 2 and 2's a factor of 8. Therefore, 8 divided by 2 is 4. The difference between 2 zeros and 1 zero is 1 zero, so Miriam could spend about $40 a day. So in our estimate, Miriam could spend about $30 to $40 each day that she is on her trip. All right, let's look at one or two more problems. Try this. Use compatible numbers, find two estimates. I'm going to try typing from here on out, though my division symbol is going to look a little bit different. We have 415 that we want to divide by 52. I'm going to start, there went my text box, by rounding the number 52 to 50. Ooh, let me erase that real quick. I got a little sloppy. All right, so we rounded our divisor 52 and we rounded it down to 50. Now I want to change 415 to something that's compatible with 50, or more importantly, 5. So if I look at the first two digits of 415, I see the number 41. If I round that down to 40 and change the 5 to a 0, in other words, if I round 415 to 400, I have to ask myself, well, are they compatible? Can I mentally divide 40 by 5? And the answer is yes, because 40 is a multiple of 5 and 5 is a factor of 40. So the estimated answer, 5 can go into 40 8 times because 5 times 8 is 40. The difference between the number of zeros between 40 and 5, that leaves 1 0 and 1 0. Notice how I divided 5 not into just 4, but I divided it into 4D for my basic fact. Since 5 went into 40, that already eliminated 1 0. So the difference between 1 0 and 1 0 is no more zeros. So my estimated answer would just be 8. I want to find two estimates, so I'm going to change 52 again. This time I'm going to round it all the way down to 40. And I'm going to change my dividend, 415. I'm going to round that down again to 400. And that is going to help me find compatible numbers because, of course, 4 and 4 are compatible together. 4 goes into 4 one time. The difference between 2 zeros and 1 0 is 1 0. So 4 divided by 4 was 1, and the difference between the number of zeros was just 1. So another estimated answer would be 10. So if I had to come up with two estimates for this division problem, I could say it's going to be about 8 or about 10. So the real answer might be around 9, but it'll be close to 8, 9, or 10. All right, here is another try this. This is also on page 114, and they want me to estimate a quotient. So I'm just going to come up with 1. Now this one appears to look pretty tough. Let's start with the divisor. You can see that 38 is in the tens place. It looks like it's a little bit closer to 40 than it is to 30. So I'm going to change it to a 40. Now, I want to look at my dividend, and I see that the first couple digits are 27. So one way that I could round this is up to 40 and change 2,764 to 40 with 2 zeros. So I'm replacing 27 by rounding it up to 40, make that a little nicer, and I'm changing the 64 by replacing them with 2 zeros. So I've rounded 2,764 all the way up to 4,000, And the reason I did that was because 40 is compatible with 40. So one estimated answer that I come up with is that 40 can go into 40 one time, and I have 2 zeros left over here, no zeros left over here since I already took 40 into 40. So I would have to add 2 more zeros to my estimated answer. So I could estimate that to be 100. Another way that I could do this is I could change 38 to 40. And again, if I want to look at this 27, I could think, well, what are multiples of 4 that are close to 27? So if I counted in multiples of 4, 4, 8, 12, 16, 20, 24, oh, I'm getting really close. 28 is the next multiple. Aha, 28 is the closest multiple to 27. So I'm going to change 2,700 to 2,800. And once again, the 64, I'm just going to turn into zeros. Now I've come up with really good compatible numbers for this division problem. I know that 4 can go into 28 7 times. And I have 2 zeros here, 1 0 here, so the difference between them is just 1 0. So 70 would be another good estimate for this division problem. So I came up with an estimate of 70. Here I came up with an estimate of 100. Which one do you think would be closer to the actual answer? I think this one would also. The reason is 2,800 is much closer to the actual dividend than when I rounded 2,764 up all the way up to 4,000. All right, here's just a few more compatible numbers that they started with in the Sharon show. You can see number 1 at the bottom of page 114. They already changed 154 down to 140 and 22 to 20. The reason is 2 and 14 are compatible with each other. So they're going to make it easy to do mentally. 2 can go into 14 7 times. A 0 and a 0 would cancel out or cross each other out, so we don't add any zeros onto the end. Same with this one. They rounded 154 up to 160 and rounded 22 down to 20. 16 and 2 are compatible with each other because 2 can go into 16 8 times. I don't add any zeros onto it because 1 0 and 1 0 are going to cancel out. The difference is no zeros, so I don't add any onto it. I hope that this video helped you to understand compatible numbers. We would like you to try your own by solving some on page 115. Go ahead and turn to page 115. And the problem that you're looking at right now, it looks like is problem number 9. So you'll have to go back and solve 7 and 8 on your own. But if you want help getting started with number 9, let's first round 28. What would you like to round 28 to? I'm thinking either 20 or 30. Which one is it closer to, 20 or 30? I agree. I think it's closer to 30. So I'm going to round it down to 30. And now right away I'm thinking, all right, well, I need a multiple of 3. What multiple of 3 is closest to 23? Let's count in multiples of 3. 3, 6, 9, 12, 15, 18, 21. 21 is really close. So let's round 23 to 21. Whoa! 23 will change to 21. And then, what are we going to do? What do we remember to add? Because we changed 23 to a 2-digit number. That's right. This number is in the hundreds. So we need to just change that 2 to a 0. Now we have compatible numbers. 210 divided by 30. I can use my basic fact. 3 goes into 21 7 times. Do I add any zeros behind the 7? Let's see. I have 1 0 over here, 1 0 over here. No, the difference is going to be no zeros. So my estimated answer is just 7.